In this section, we're going to talk about two mathematical concepts that are related to each other, the greatest common factor and the least common multiple. We'll start by looking at the GCF, the greatest common factor. What this is it's the largest factor that two or more numbers have in common, and we're going to examine how to find this in two different ways. And that's what the next two examples are all about. So one way that we can do this is by simply listing the factors of each number. So take 45. We've got 1 and 45. 2 isn't a factor. 3, yeah, 3 goes in there. 3 times 15 is 45. And finally, 5 goes in 9 times. Then we take 75. List the factors there. 1 and 75. 2 doesn't go. 3 and 25. And finally, 5 and 15 are factors. So let's start by looking at the common factors. First, understand that the word common means that they both have to have that as a factor. So let's look at these lists. What do we see in common? Well, there's a 1 in both lists, there's a 3 in both lists, there's a 5 in both lists, and there's a 15 in both lists. So our list of common factors would be 1, 3, 5, 15. Now, of that list, what is the GCF? The greatest common factor. Well, we want the largest number in the list of common factors. It's 15. There we go. That's all it is. We list out the factors. We find the one that's on both lists and the biggest. Our second method relates to the tree diagrams that we were using for prime factorization. We're going to do the exact same thing with these tree diagrams. So we start with 45. 45 is 3 times 15. 15 is 3 times 5. So our prime factorization for 45 would be 3 times 3 times 5. For 75, we have 5 and 15. 5 is prime. 15 is 3 times 5. Now what we're looking for here is we're looking for the things that are in common to both trees. So there's a 3 in the 45 tree. Is there a 3 also in the 75 tree? Yes. Yes, there is a 3. So in my GCF, I'm going to write down 3. There's another 3 in the 45 tree. Is there another 3 over in the 75 tree? No, there is not. So this will not be part of my GCF. Now there's a 5 in the 45 tree. Is there a 5 in the 75 tree? Yeah, right there. So as a part of my GCF, I'm also going to list a 5. So far I have 3 times 5 as a part of my GCF. And my 45 tree is all used up. The only thing left that I haven't looked at is the extra 5 in the 75 tree. But, well, there's not another 5 in the 45 tree. So my GCF, the only factors that they have in common is 3 times 5, also known as 15. So I would like you to pause the video now and try to find the GCF for 56 and 80. So I'm going to go about this using the tree method. I think that makes the most sense for me. So I start with 56. That's 7 times 8. 8 is 4 times 2. And 4 is 2 times 2. 80. 8 times 10. 8 is 4 times 2. 4 is 2 times 2. 10 is 5 times 2. So let's go through these trees and find what they have in common. Do they both have 7s? I'm looking right here. Do they both have 7s? No. Do they both have a 2? Well, yeah, they both do have 2s. They've got a 2 here and here. So as a part of my GCF, I'm going to write 2 times. Now there's another 2. Is there another 2 over here? Yes, there is. There's a pair of 2s, so that 2 is in common. We write that down as part of our GCF. I have another 2 in my 56 tree. I have another 2 in my 80 tree. So there's another 2 in common. We write down one more 2 as a part of the GCF. Now in the 80 tree there's also a 5, but this tree there's no 5. There's another 2. Is there another 2 over here? No. So my GCF is simply 2 times 2 times 2, or 8. Let's change gears slightly, and now let's talk about the least common multiple. It's the smallest number that has both or all of the numbers that we're looking at as factors. Whereas the greatest common factor will always be smaller than the numbers that we're working with, the least common multiple will always be bigger than the numbers that we're working with. And again, we'll look at 2 methods for doing this. We're going to start our first method by making a list. So I want the least common multiple of 6 and 9. Okay, so let's start by listing the multiples of 6. Multiples of 6 are 6, 12, 18, 24, 36, and so on and so on and so on. There's 42, there would be 48, and so on. I could keep listing out multiples. And then we write down the multiples of 9. 9, 18, 27, 36, and so on and so on. There are infinitely many multiples. What I'm looking for is the least multiple that they have in common. So we look at the list. We're looking for multiples that they have the same. There's a multiple of 18 that's on both lists, and 36 that's on both lists. And if I were to keep listing, I would continue to find more and more multiples in here. So what's the least common multiple? Well, the least common multiple will be the smallest one that I see in both lists, and the least common multiple is 6 and 9 is 18. My second method is using a tree diagram again, using a factor tree. So 6, if I find the prime factorization, it's 3 times 2. 9 would be 3 times 3. And what I'm looking for is I want to write down everything that I must have to make these numbers. So to make 6, I'm going to need a 3 and a 2. To make 9, it says I need 3 times 3. Well, I already have a 3 right there, so in order to make 9, I'm going to need one more 3. So now in this product that I've written down right here in the box, I have 3 times 2 to make my 6. And I can also look at those numbers as having 3 times 3, which makes 9. So these are all the factors that I need for my LCM. My least common multiple is 3 times 2 times 9, better known as 18. So we have looked at LCM, GCF. You have to know what those letters mean, and you have to keep straight what it means to be a factor and what it means to be a multiple. Keep in mind that factors will always be smaller than the numbers that you're working with, and multiples will always be greater than the numbers that you're working with. And with that, I leave you and wish you a fond and wonderful day.